Hello everyone. We have experiment one, part two. So, mm, so you have experiment one instructions here. So we did part one last week, area measurement and particle counting. So we have part two. Uh, Part two itself has two parts inside, uh, which is the amoeba muscle analysis, and the second one is the wound healing. The mm, You have to use manual tracking in ImageJ to analyze the wound healing video. You have to track the particles down there. So you have set of instructions here, and you have instructions here as well. So go to experiment one instructions. So we did this one, like area measurement and particle counting. Now we have to do amoeba muscle analysis. So the amoeba muscle analysis, to analyze the amoeba muscle, you have to download the image first, and then the second one is the wound healing video. You just have to download both of them. So for that, go to home, and then experiment one right here. I have already downloaded those two files, so you just want to download this amoeba.png and woundhealing.api. So once you download those files, uh, mm, go to instructions one, experiment one instructions here, down there. First of all, you have to use ImageJ. Make sure you have ImageJ installed. Otherwise, you have another way you can install image. You can access ImageJ through virtual desktop. And just let me know if you don't know how to use virtual desktop. Uh, uh, in case you don't have ImageJ downloaded. So first you have to use ImageJ to open the file amoeba.png and set the scale of the image using y-axis, and you have to use the point tool, and you have to click at the center of the bead, and then you have to hit Control M to get the data in, and finally you will be copying and pasting that data into the Excel, and you will plot the graph for velocities, instantaneous and average velocities, and position, and eventually the instantaneous and average accelerations. So let's move forward. So first of all, we have to open this file and set scale using y-axis. So ImageJ, let me go to file, open, and then amoeba here, open here. So second step, we have to set the scale using straight line tool, just like we did in part one. Let's use a straight tool, and then draw a line from you can draw a line from 0 to 200, 150, whatever you like. I just want to draw from 0 to 50. The length is 50 micrometers. You can see the unit here, micrometers. So now we have to set a scale, and I'll go to analyze, set a scale, and then in non-distance just write 50, and unit is write down UM means micrometers. Don't just write mm. Okay, mm means millimeters. So write check global, and then okay. Now we set the scale. If you have something to remove, then go to just edit, selection, and select none, and everything gone. So choose another tool, I think this is the multi-point tool. This is the multi-point tool. So choose a multi-point tool and then click at the center of the bead like that. You can and hit Control M or Command M, and then you should be able to see the data here. So yeah, so now open Excel. Let me open Excel here. This is the blank file. So copy that data to copy all. Just right. If you are using Windows, then you can type Control A. I would use Control A, Command A in Mac. So and Command C for copying, and then here Command V, paste. So yeah, now we just done at this one. We done at this one as well. So yeah, we done at this one. Okay, let's just cancel it for now at least. So what I want to check is if the data I have got is correct. So go back to canvas and then one more back, and then experiment 1 instructions. So go to part 2 and go to command lab, Excel command lab, and you have a data here. We need x and y values. Okay, so if you compare the data, the first data is 7.7 to 1.5. It is very close. Okay, and 240, 71.91, 226, it is pretty close. So we are getting good data. So put everything in our Excel file, like that Excel command here, right down here. Let me so we just need x and y. We don't need we just don't need those. So let me delete this entire column, and okay, so we need one column for numbering, so one for time, and so I want to add two extra columns there. So insert and then entire column, that oh oops, what's going on? Oops. Okay, let's try one more time. Insert entire column. Yeah, there you go. Now you want to add another one. Insert entire column. Yeah, this is for numbering. We can just write num. Oops, we want to add one row as well. So insert entire row right there. So this is just a num, and you can write one. So equal, and then select the first one and plus plus 1. So you want to drag it down like that. So this would be time. So it should be, first would be 0, second one would be 180 seconds, and third one would be equal first one plus 180, and just drag it down. Yeah, is that right? Let me just double check. Oh, 1800, 180, 360. Oops, here I have clicked one particle double here, so we just want to remove this one. So we're going to remove this one. So you're gonna drag it down here, to here, and drag it down here like that. Okay, you're good now. So this is X, this is X, this is Y. So this should be displacement R. Let's just write simple R, and then like so you can see formula here. So make sure you have 0 for the first value, and for the second one, so you have to use this formula. So equal, you have to use this equal c3 should be, oh wait, square root first. Yes, q rt square root, and two bracket open, and then c3 minus c2 bracket closed, and that should be money sign in between, and you can use money sign in front of the c as well, but it should be okay. So square c3 minus c dollar t square plus and bracket open again, and d3 minus d2, and you should use money sign down there, yeah, and square bracket close, and oh, that's 15, yeah, it's 13.36, and it should be fine. So drag it down all the way there, yeah. So let's go to instantaneous velocity. V instantaneous. So here just leave it as it is, don't write anything in there. So for instantaneous velocity, e3 minus e2, v3 minus v2. So here just write equal bracket open, e3 minus e2 instantaneous velocity. That should be rate of change of displacement, right? So this is e3 minus e2 bracket close divided by, and should be time now, time v3 minus, oops, let's use the bracket here, v3 yeah, minus v2 bracket closed, just enter, and 0.074, and it's little more, but 0.074. okay, that is closed. Yeah, so now drag it down, just drag it down, yeah. Now be instantaneous, a instantaneous, I just find inst. So you can write unit like it has written here, so just leave one space down there, equal instantaneous acceleration, right? So for the instantaneous acceleration in column Z, f4 minus f3 bracket open, f4 minus f3 f4, is that right? No, it should not be that. It should be f3 minus f2, f3 minus f2, nothing in there, and divided by v3 minus v2, v3 bracket open, v3 oops, b3 minus b2. Is it close? 6.3 into 10 to the power minus 4. Yeah, it's a bit close. Yeah. Now here we average avg. So here is very equal. Average would be e3 minus e$2, bracket open, e3, this will be this one, 3 minus e$2, e$2, and put money sign in there. Oops, e3 minus e$2 and put money sign there, and bracket close, divided by b3 minus b2, bracket open, v3 minus b2, like that. Just 0.084. okay, just drag it down, b average, and then a average, acceleration average, avg, and equal, and for the average acceleration the formula would be s3 minus s2 equal, bracket open, s3 minus s2, s3 minus s2, and put money sign there, and then bracket close, divided by time, this one minus this one, bracket closed, and bracket open there, and then enter. Okay, and drag it down. So yeah, we are all set for the data. And so what we have to do now is so you have to plot a scatter plot for position versus time. Yeah, you have a position x and y here, and instantaneous and average velocities versus time in one single plot, and scatter plot for the instantaneous and average velocity versus time in another plot, and copy and paste these graphs into Word document and write one sentence description for per graph. So now let's do the first one, scatter plot for position versus time. So this is really important part where most of the students are confused about. So just to plot the graph, just choose one of the cell here, and then insert, and then this is the scatter plot. Okay, let's choose the blank one, just drag it down here, and then select this chart, and then select data, and then if you are using Mac, and then this plus sign is the yard. Okay, if you are using Windows, then you will see yard option in there. So let me add, and then series one would be so we're gonna plot position versus time, right? So let's plot x versus time first, x versus time. So x, let's just write x versus time, x versus t, and then x values would be, always choose time for horizontal axis. Oops, and then for y values, choose x values, and here click OK. Yeah, so you have select this one, change sort type, line, and then yeah, nice. So yeah, we got this. Now you're gonna use trend line. So if you use trend line, like it shows a decreasing trend, but let me try another one. You can you can chart data type, line, and then you can select this one. Yeah, this looks nice. So you want to add y versus time in the same graph as well. So so again, go to select data, and you want to add plus sign again. So in series 2, whoops, what are the x values here? Oh, okay. Name, name. So name is y versus time, and then you want to select y values right there, and then okay. So yeah, so now this is x versus time, and this is y versus time. You want to add legend on the right, and you want to add mm, you want to add access titles. Vertical would be velocity. So go back to chart title. Oops, horizontal should be time. It is time, and vertical would be velocities. Velocity. Velocity strike. Velocity. Okay, and then is there anything there? You can just write chart title, axis titles, chart title, above the chart. Mm, you can simply write velocity versus time. Velo, velocity versus time graph. Okay, yeah. So likewise, you have to let me minimize. Now, secondly, you have to plot instantaneous and average velocity versus time. So, and choose another scatter plot, and then now select data, and add series 1 would be v and instantaneous versus time. So x values would be time, x values would be time, and y values would be velocity instantaneous, and then just click OK, and then you see this. So again, go to change chart type, and then line. You can simply select this one. Yeah. So now select data again, just add plus sign there. Name. I think that the 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 box for the x values is not showing here, because that should be even that is not showing in there. That should be okay, because we are using the same time for horizontal axis. So name v average, avg versus time, and then y values would be v average. This one is the v average, like that, and okay, yeah. So now you want to Okay, now you are done with graphs. So you want to export it, you want to save and export into Word, and you have to describe each graph with at least one sentences. Okay, for example, for this position versus time, you can simply write x versus time seems to be constant with time because it is not changing, and y position is decreasing with time. Okay, you can write down that. Yeah, and for the velocity versus time graph, this is increasing, this is constant, this is increasing, like that. You need a one sentence description for each graph. So you are done with part one. Okay, now you are done with part one. Yeah, so let's just save it. Oops, let's just save it. Save as. So let's just save it to desktop. Okay, let's not save it to desktop. Documents, and then this is part one. This is part one. Excel files and save. Okay,